Hello, everyone. Hello, everyone. Good afternoon. Is my voice clear? Let me check. Give me quick recap. Is the screen visible to you? And is the voice clear? Yeah. Okay. Now I'm going to start regarding the machine learning methods and all. Right. What do you mean by machine learning? Anyone? What do you mean by machine learning? Machine learning? What is ML? Machine learning means it is the study of computer algorithms that can improve automatically to experience, okay, by how to use the data and all. Okay. Right. And what are the types of machine learning? Machine learning means it is the study of computer algorithms that can improve. What are types of ML? What are the types of ML? How many types we have? We have what are the types of machine learning? Supervised and unsupervised. Right. Supervised and unsupervised. Yes. Okay. Yeah. What do you mean by supervised machine learning? What is supervised machine learning? Anyone? What is supervised machine learning? Yes, Srinidhi. Srinidhi, what is supervised machine learning. Supervised means the name itself tells you about what? Label data. Yeah. Supervised means it is label data, means you know the output, right? Supervised means in machine learning algorithm, you can say that it trains the model. Okay, the input is already known, right? And the output data also, it can predict. Okay, it can predict future outputs. So supervised learning means it trains whenever you develop any algorithm, it trains the model and on the known inputs and it predicts the output data, right? Then what is unsupervised learning? Yes, Satya, good. The output is known. Unsupervised learning means which finds the hidden patterns of your data, which finds the intrinsics, depending on the intrinsic structure and the hidden patterns of the input data. Okay, and it gives you the output, and here the output is not known. Okay, yes. So from here, how can you define that? What is the main difference between the supervised and unsupervised learning? What is the difference between supervised and unsupervised? What is the difference between supervised and unsupervised? Let me wait for the quick answer. Please give your quick answers so that I can able to know. Yes, the supervised learning, it uses the labeled input and output data. Okay, while an unsupervised learning, it not uses it, right? It uses supervised learning uses labeled input and output data, and it gives you the output data. And unsupervised learning algorithm, what it gives, we don't know the output. Why is not known. It is the main difference. Perfect. And what is reinforcement learning? What is reinforcement learning? Srinidhi, Satya. Only these two people are answering. What about the remaining? Reinforcement learning means it is the area of machine learning which concerns with intelligent agents or to take actions. Means here environment will be there, and there the agent will take actions, right? It is an area of machine learning concerned with how the intelligent agents ought to take some actions, okay, in an environment called in order to maximize the notation of cumulative reward, right? As of now, we are discussing about supervised learning. Okay. So if you see how many categories of how many types of algorithms you have in supervised learning? This is the question. How many algorithms you have in supervised? Are there? How many types of supervised learning are there? How many types you have? Let me check. Can you name it, Satya? Can you name them? No, Satya, not 3. And anyone? Totally, there are 5 people. Only Satya is giving answer, and the Srinidhi. How many types of supervised learning algorithms we have? There are 2 types only. What are those? Classification algorithms and regression algorithms. How many types of supervised learning we have? We have 2 types of categories of algorithms we have. The first one is classification and the second one is the regression model, right? Now, can you say what is, can you explain classification algorithm? This is my next question. Please answer. Explain in classification algorithm. Right. Explain classification algorithm. If you got any business problem from your client, then how can you identify this problem, this regarding business problem belongs to classification? How can you able to identify that? How can you able to identify a particular problem belongs to classification? Using classification algorithm, we are able to solve it. Satya, test versus train. Test and train, no. If the problem output supervised algorithm means we know the output, we know about the output, we have some idea, right? So whenever we are having the output variable as a category output variable, so means if the patient, suppose if the patient is having cancer or not, yes or no, okay, that particular disease is the patient is having or not having, okay, disease, no disease, or if any color is means is it white or black, is the color is red or blue, yes or no, that gives you the classification algorithm. Okay, in that situation we have to use the classification algorithm, right? Now come to the second one. What is regression? Regression. Let me check. Here you have regression problems always deals with when output variable is a real value. If you have the output variable as real value, then that particular problem belongs to regression algorithm, right? For example, the output may deals with the dollars or any rupees and all. Or if the output is dealing with the weight of a person, weights of a person, if particular patient is gaining or losing his weight and all that. So if the output variable is a real value, then that particular problem belongs to regression. Then we have to apply regression techniques on that business problem, right? Yeah. If you see inside, What are the types of regression you have? Yes, anyone? Please give your reply. How many types you have? Yes, very good, Keshav. Linear regression, logistic regression. Polynomial regression. Yeah. Lasso regression, ridge regression, random forest regression, decision tree also comes under that. Right. So how many types of regressions we have? Linear regression, logistic regression, polynomial regression, support vector regression, decision tree regression, random forest regression, ridge regression, and lasso regression. Yes. These are the types of regression in case of regression analysis of machine learning. Right. Now, let's see about linear regression. So, what's the next question? What is linear regression in machine learning? Okay, what is linear regression? Anyone? Yeah, linear regression is a supervised machine learning algorithm. It is a supervised machine learning algorithm where the predicted output is continuous and it is having some constant slope. So you can say that linear regression is used when you are going to use it. Linear regression is used to predict values within a continuous range because it is the output of this particular algorithm is continuous. right? Now, my next question is, yes, Satya, Y is continuous. Now, my next question is, why we are using why to use linear regression algorithm? What is the purpose of using linear regression? Generally, regression models predicts the value-based independent variables, right? So this particular linear regression model is used for finding the relationship between the variables and the forecasting. So in order to find the relationship between the variables and forecasting, we use ML. Yeah, I think it is clear why we use the linear regression. Okay, to predict the output value, we use that. Now, what example can you give for this? My next question is, what is the example of linear regression? In your real life, where do you use the linear regression? What is the example of linear regression? In your daily life, where can you find it? Anyone? If you see, you may know that in order to determine the body weight, you may use the height of that particular person, right? So suppose to you know the relation between the weight and the height, isn't it? So you can take it as an example of linear regression. Using weight was the weight is used to determine the body weight height, okay, or the height be used to determine the body weight. Depending on the height of that person, you can calculate the body weight. This is example of linear regression. Yes. Now, my next question is, what is logistic regression? What is logistic regression? Yes, please give me your quick answers. What is logistic regression? So this is a process of modeling any algorithm or the process of probability of a discrete outcome given an input variable. So you can say that logistic regression belongs to statistics. Okay, it is a statistic algorithm. Okay, if you want to use this logistic model, the probability of any certain class or any event you have to consider. So the probability of a certain event which is existing, is it live or is it healthy or sick, like that you can able to classify it, right? So you can say that logistic regression is a statistical model that in its basic form means a logistic function to model a binary dependent variable. You can call it logistic regression. You can call it as a logic regression also. Right. Then what is where we use, what is the use of logistic regression? My next question is, what is the use of logistic regression? What is the use of logistic regression? Yes, Satya Naidu, it is probability. Yes, good. So it is used in the statistical software to understand the relationship between the dependent variable and one or more independent variables. How can you able to predict the one or more independent variables? How can you able to give the relationship? By estimating the probabilities, right? By estimating the probabilities. I mean to say that it is a type of analysis which helps you to predict the likelihood of an event happening or unlikelihood. Okay, I'm repeating it again. So when can you use the logistic regression in order to get the, in order to understand the relationship between the dependent variable and the one or more independent variables by using probabilities, okay, by estimating the probabilities. Okay, here what we use, here we first we have to build some equation, logistic regression equation we have to do. So for this is in this particular analysis, what are you doing? You are taking the help of logistic regression equation in order to predict the likelihood of an event happening or a choice is going to happen or not. Right? Clear? Now, as of now, we came to know some, we have some idea regarding the linear regression and the logistic regression. Right? Linear regression and the logistic regression. Now, my question is, till now, you know these two types of regressions. I'm asking you, what is the difference between linear regression and logistic regression? Anyone? I'm waiting. What is the difference between linear regression and logistic regression? Yes, Punyamurti, I said, what is logistic regression already? If you want, I can repeat. Logistic regression means in order to understand the relation between the dependent variables and independent variables, we use this logistic regression, and you are able to know the likelihood of happening of an event or not happening of an event. You can able to know, right? The output of this logistic regression will be discrete. Remember that. Yeah. So here, as I said, logistic regression outcome is happening or not happening, or likelihood you can able to predict. Okay, yes or no, you are going to say. So of course, the name itself is like regression. Okay, but here, what is the thing? Logistic regression is useful to analyze the classification problems in order to determine the category. And linear regression, it handles some regression problems. Regression problems means the output will be, what is the type of linear regression output? Continuous. Linear regression provides you continuous output. Logistic regression is output. Logistic regression provides you discrete output. You have to remember. Right. It is important. Continuous output, where do you get the continuous output? Continuous output for yes, Bindu Prakash, continuous output is for what? Linear regression. For linear regression, right? And discrete output for discrete output for logistic regression. Yes, right. Next, my next question is, yes, Banu, logistic regression, discrete. Good. What is polynomial regression? What is polynomial regression? It is also belongs to statistics. So in statistics, polynomial regression means it is a form of regression analysis. It is also statistical analysis. Okay, so it is a form of regression analysis in which the relationship between the independent variable and the dependent variable is modeled. How it will be modeled? How it will be modeled as nth degree of the polynomial in terms of x. The name itself tells you the polynomial, right? So nth degree polynomial we will get. It is also you can consider this polynomial regression. If you have done the data science full course, you might have gone through this, right? While doing the multiple linear regression, you might have got this. So you can say that it is polynomial regression also for the statistical analysis. Okay. It is a form of regression analysis in which you can find the relationship between the independent variables and the dependent variables. How can you find the relationship? It is in the form of nth degree polynomial. Yes. Okay. Yes, Leon. So here we are using independent and dependent variables and all. What do you mean by independent variables? Anyone? Anyone? I'm waiting for your answer. What is independent variable? Independent variable means you can consider it as the X variables, right? And dependent variables means you can consider the, yes, features. Bhanu, good. Bhanu Prakash. So independent variables are considered as the X, which affects the Y values. Okay. So you can say Y values means Y variables means dependent variables. Independent variables means X variables. Dependent variables means Y variables, right? So here in polynomial regression, you are going to find the relationship between these X and Y depending on the nth degree polynomial in terms of X. So you have to write the equation like Y equal to so X, like that, right? There you may have the B and the BX, Y equal to B plus BX plus and so on, like you can get. Okay. So you can, where can you use this polynomial regression and all? In order to, it is used to study of isotopes of sediments. They are using the polynomial regression. Okay, because it gives you the great defined relationship between the X and Y variables, the independent and dependent variables. So they are using this polynomial regression in the study of isotopes of the sediments. Okay. Now, my next question is, what is SVR? What is the full form of SVR, guys? What is the full form of support vector regression? Sorry, SVR. SVR means support vector regression, right? What do you mean by? What is support vector regression? The name itself tells you that it is a supervised learning algorithm which is used to predict discrete values. Right. What values do you predict here? Discrete values you have to predict. Right. So here the main thing is the basic idea of support vector regression is to find the best fit line. Okay, if you take the graph, if you take the support vector regression graph, you may have the dependent and independent variables, right? So there you have to find the best fit line you have to find. Best fit line you have to find. How can you say a line is the best fitting or not? Best fit line means it is a hyperplane that has the maximum number of points, that is having the maximum number of points. If your line is having maximum number of points, then you can say the particular line is the best fit line, and that line be developed, using the supervised learning algorithm, which is called the support vector regression, right? Yes. Now, let's move further. What do you mean by, my next question is, what is decision tree regression? What is decision tree regression? Any one of you, please give your quick answers. So decision tree means here it is a regression as well as classification models it can able to build. Decision tree means as a regression or classification models it can able to build in the form of a tree structure. Means it breaks down the data set into smaller subsets. Okay, and at the same time, it associated decision tree means it developed some relation between these two. Okay, between the subsets. The final result will be of the tree is with decision like nodes and the leaf nodes. What you have, I'll explain tomorrow regarding the decision tree. In this decision tree, nodes and leaf nodes you have. Okay, so what can you say? Decision tree regression, decision tree builds classification model as well as the regression models it can able to build in the form of a tree structure. It breaks down a data set into smaller and smaller subsets. And also at the same time, it develops some decision. Okay, decision it will develop as a form of nodes and lists, right? Okay, here we are saying decision tree, it is going to predict some values. How it can able to predict some values? It is a form, it is a structure of tree. It predicts the future. Okay, it predicts some data, some decision in the future, which will be happen, means it will give you the meaningful continuous output, right? So decision tree regression, it observes the features, whatever features you give to it, okay, and it makes subsets of the data, okay, to make some subsets of the data. Then what it trains the model. After that, what it will give you, it predicts the data and it gives you the future prediction as a meaningful continuous output, as a continuous output. So you can say that the output of the decision tree is continuous. Right. Today, I'm going to give you the just what are the types of regressions and all we have, and what are the classification and regression models we are having. Okay, and tomorrow I'm going to give you some idea regarding what are the metrics depending on all these models. Okay, how you are able to calculate your data model. Okay, yeah. Now my next question is, what is random forest? What is random forest algorithm? So you can say random forest algorithm is a supervised learning algorithm which uses the ensemble learning methods for regression. What it uses? Ensemble learning methods. What are those and all? Tomorrow I'll continue. What are those ensemble learning methods, and what we are going to, how you are going to predict, how you are going to predict the values of the data, how you are going to assumptions, either the person is having disease or not having that disease and all. Okay, I mean to say, are you going to calculate the accuracy, and when you are going to use that accuracy, and how the assumptions are made, and what are the ensemble techniques, okay, ensemble learning methods for regression, how you are going to apply those on your data set and all, I'm going to discuss tomorrow. Okay, right, Banu Prakash? Yeah. Okay, guys, thank you for attending the session. I hope you have got some idea regarding what is supervised learning model and unsupervised learning models. And first thing, what is machine learning? And what are the types we have, where we are going to use those. Okay, tomorrow onwards, I'll go to the metrics, what we use in all these algorithms, right? Thank you so much for attending this session. Bye.